All right, everyone. Today we are going to learn how to factor. Notice it says factor. How we're going to factor what's called perfect squares. Now, when we're doing perfect squares, um, sometimes we have a GCF to take out before we start. But we did kind of cover this already in this class, but back then this was just an x squared. So let's go ahead and get started. So if while you're working on this, you notice that this is a perfect square, and this is a perfect square, then you could factor. And so if I think about 16, that is like 4x. I'm sorry, that'd be 4 and 4. Getting ahead of myself. 4 times 4 is 16. Now, x to the fourth, remember, to be a perfect square, it has to have the same width and the same length. But anything with an even exponent, I could split up evenly. So if I have 4x to the fourth, that means x, 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 x. So that's 4 of them. So I'll just put 2 with the width and 2 with the length. So I'm going to put this as 4x squared. And I'm going to put this as 4x squared. Okay. Now, same thing with the 81. 81, I could put that as a 9 and 9. And then if you have x and x, you could split those evenly and just put one as an x and the other one as an x. So putting all that together, I would get 4x squared plus, and I just realized something. What I just realized is I really should take out the GCF. So that's my mistake. So what I'm saying is I noticed that there is so 16 and 81, there's nothing that goes into 16 and 81, but x to the fourth and x squared, that has a GCF of x squared. So I really should take out an x squared, which leaves a 16x squared minus 81. Okay. And then from there, doing the perfect squares. Oh, where are you? I'm not very good at drawing squares. But doing the same thing, 16x squared, I could break that up into 4x and 4x. And then for 81, I could break that up into 9 and 9. So putting all that together, I would have my x squared on the outside. And then I'd have 4x plus 9, and then 4x minus 9. And that would be all. Now, as a reminder, you always look for a GCF, and I almost made that mistake. I could have factored it out at the end. And then if this term and this term are perfect squares with a minus, you could factor. Okay. Now let's do number 3. Number 3 does not have a GCF. There's nothing that goes into x to the fourth and 25. But I do notice that both of these are perfect squares. X to the fourth, if I take x, 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 and break them into 2 groups of the same, that'd be x squared and x squared. So I got x squared and x squared. 25 is a perfect square. I'll put 5 and 5. Putting all that together, I'd get x squared plus 5 and x squared minus 5. And then there's some teachers that will have you break this into square root of 5. Trying to decide if I want you to do that. It's probably okay like that. So what I'm saying is, I'll show you what I mean in this next one. So like 81 is 16. You know, there is, see, GCF of 81 and 16. Looks like the only number they have in common is 1. So there's no GCF. And I could have worked that out. My brain is not working yet today. But so I would break this into squares if I can. This one would be 9x squared. Because 9 times 9 is 81. X squared times x squared is x to the 4th. That would also be 9x squared. And 16 would be 4 and 4. So putting all that together, I'd get 9x squared plus 4 and 9x squared minus 4. Now, this is what I was talking about. So technically, and I'm going to do that over here to give myself more space, but technically I have perfect squares again. Look at this. 9x squared is a perfect square. 4 is a perfect square. 9x squared is a perfect square. And 4 is also a perfect square. Now, just to save time, I'm not going to put the length and the width, but 9x squared would be 3x and 3x. 4 would be 2 and 2. So for this part right here, I would get 3x plus 2 and 3x minus 2. Now, it's been a while since we've done these, but we learned that if there is a plus sign here, then that produces an imaginary root. So because this has a plus, I need to save a spot for an I. So this is going to be 3x plus 2i, 3x minus 2i. And we talked about y last semester. Okay, so this comes out of here. Now 9x squared minus 4, let's see. It's still going to make 3x and 2, 3x and 2. And these all go together. But because it's a minus, you don't need the I. So we had 9x squared plus 4 making 3x plus 2, 3x plus 2. Because of the plus, I needed an I. This makes 3x plus 2, 3x minus 2. Because there's a minus, you don't need the I. So that's putting together a few skills from the semester. So final answer 5 is this. Now, why didn't we take this a step further? We actually could have, but most of the time people don't take that a step further. So like, because 5 is not a perfect square, but technically you could say, okay, that's x. And then instead of using 5, you could use square root. So you could have said plus square root of 5 and minus square root of 5. And remember, because of this plus, you would need an I. That comes from this first part. And then x squared minus 5, you would still do x plus square root of 5 because square root of 5 times square root of 5 is 5. So you may see some teachers that do it this way. I mean, it kind of depends. I'm pretty sure the district assessment doesn't have any numbers that aren't perfect squares. So you can either stop here or here. But on number 5, if the numbers you work with are still perfect squares, you keep going. All right, let's do another one. What is the square root of 125? You can't take the square root of 125. And is there a GCF of 81 and 125? Yeah, I'm very busy. Okay, so it's 1. The only numbers that go into 81 and 125 is 1. So this is a bad example. There's no way to do this without breaking the square 125 in the square root of 125. So this one I would say 125. I would say 81 and 125 has no GCF. And 125 is not a perfect square. So that one was a bad example. Okay. Let's do 9. 9, I noticed that they're both even. So let me think, what's GCF of 16 and 36? I think it might be 4. So let's take out the 4. And that would leave 4x to the 4th minus 9. Okay. And then I could break this into perfect squares. So that'd be 2x squared and 3 and 3. So this becomes 2x squared, that becomes 3 and 3. So putting all that together, I'd get 4 on the outside. And then I would have, for this part, that'd be 2x and 2x. I guess it'd be 2x squared. And then for this part, that'd be 3 and 3. And then putting all that together, I do 2x squared plus 3, 2x squared minus 3. I'm trying to color code this one a little bit better for you. So that's plus 3 and 2x squared minus 3. And remember, if this was a plus sign, I would then add an I here and an I here. And then from here, I would not mess with square roots. So I would not take this a step further unless 2 and 3 were perfect squares, which they're not. So I did half the page for you. The problems on the right are just like the problems on the left. So I would work through those. And yeah, that's all I have for today. Well, it's nice seeing you and hope you have a great day. Just finish the rest of the problems. And on this problem, if the number is not a perfect square, I'd probably just stop. But notice a problem like this, they're both perfect squares, so I kept on going. So hope you have a good day. Let me know if you have any questions. All right, bye-bye.